Good afternoon. Am I audible to you?
Yes, it's audible.
So we shall wait for 2 minutes. Okay, and start.
हाँ इसमें भी हो गया ना सब ये लकड़ी निकालो सबसे पहले ठीक करेगा सबसे पहले इधर लगाना है इसको ये इधर ही लगेगा
Okay, shall I start?
Yeah, please proceed.
So last class we have discussed about theory of machines and some inversions. So we have studied inversion of four-bar mechanism and also inversion of single Sladkang mechanism. These are things what we have discussed in the last class. So in that discussion, we have named various things like link, kinematic chain, etc. But we have not defined it properly. So in this class, we will be defining all the terms relating to that four-bar, single-side rectangle, etc. And we will be also discussing the last slide about inversions of double slide rectangle mechanism. So first, in the last class, we have just mentioned about all the things, but we have not discussed it in a good way. So this class we will be discussing all those things. Okay. So this is the definition what you say about theory of mechanics. So theory of mechanics. Hello.
Messenger of the Lord, not a prophet or prophetess, and we call her prophetess. How do you reconcile?
So theory of machines. So before going to theory of machines, so this is basically an extension of mechanics. The branch of scientifically analysis deals with the motion, time, and forces is known as mechanics. So we have already studied. Here in mechanics, what we study is about motion. We will be studying about motion, time, and forces. Okay. So these comes under mechanics, motion, time, and force. So this is the first thing what we are going about theory of mechanics. Then comes under the theory of machines, or so I have told you what is the difference between a mechanism and a machine in the last class itself. So machine, when it comes to a machine, it will be doing some useful work, or some energy will be converted, or some mechanical energy will be converted into some other energy, or mechanical energy, or if it is a rotary motion, it will be converted into reciprocating motion. Like that, some mechanism will happen, or one useful work will be generated. At that case, we will be saying it as a machine. So theory of machines, there are two subdivisions. One is kinematics. So kinematics means, so kinematics of this we have studied in the last class itself, but before going to general terms, I am just introducing these things. Okay. So can you mute some of your are unmuted? Okay, please mute them. So kinematics of machine is concerned with the motion of parts without considering the influencing factors such as force and mass that affect the motion. Okay. So the kinematic deals with the fundamental concept of space, time, and the quantities, velocity and acceleration derived from them. Okay. So in kinematics, they actually deal with velocity and acceleration. Okay. They will not be dealing with the influencing factors such as force and mass. Okay. So without considering influencing factors, they will be considering the velocity, acceleration, time, etc. That comes under kinematics. So kinetics means it deals with the inertia forces which arise with the combined effect of mass and motion of parts. So inertia effect, when you consider inertia effect, it comes under kinetics. When kinematics and kinetics are considering together, we get what? Dynamics. Okay, when kinematics and kinetics are considered together, what you will get? You will get dynamics. So these are some questions about theory of machine. Okay, you can go through that. Next is mechanism. So mechanism means, so I have told you last class we have studied about 4-bar mechanism, strider crank mechanism, etc. Okay. So what is mechanism means? If number of bodies are assembled in such a way that the motion of one causes constrained or predictable motion to the other, it is known as mechanism. So there are some terms known as constrained motion. So what do you mean by constrained motion? Okay. Constrained motion is nothing but if you are placing a, so for example, if you are placing a round bar in a hole, what is the specialty of this round bar? It can slide inside this round hole, or it can also rotate inside the hole. Okay, so these all are motions. But in one way, if we are stopping any of the motions, for example, we are just allowing it only to rotate, that type of motion is known as constrained motion. Okay, that is motion is restricted to one direction or one motion, that comes under constrained motion. So mechanism means if a number of bodies are assembled in such a way that the motion causes constrained and predictable motion to the other, it is known as mechanism. Then a machine is a mechanism or a combination of mechanisms which, apart from imparting definite motion to the parts, also transmit and modifies available mechanical energy into some desired work. If some work output is there, then it comes what? Machines. Okay. For the specialty of machine, what will be there? Some kind of desired work output will be produced, then it becomes a machine. So the definition of machine is a mechanism or a combination of mechanisms which, apart from imparting definite motion to the parts, also transmit and modifies the available mechanical energy into some kind of desired work. So some kind of desired work is achieved, it forms a machine. Next thing is, what we are going to study is link, kinematic link or element. For example, if I am drawing it, basically we have studied these things, but in different inversions, etc. But the thing is that if you are asked what is link, you should be able to explain, or you should be able to understand what is a link. So it is an important criteria over here. So what is this? In the last class we have studied. This is a single slider crank mechanism. Single slider crank mechanism. So this is a single slider crank mechanism. This is known as frame. Okay, this is crank. What is specialty of the crank? It will be rotating. Okay, this is the connecting rod, and this is the piston or slider. So one slider is there, that is why it is called a single slider crank mechanism. Okay, is it clear why it is called a single slider crank mechanism? We have studied in the last class detail about this single slider crank mechanism. Okay, so what is a link? What do you mean by a rigid body? So what do you mean by rigid body? Can anybody? What do you mean by rigid body? Can anybody explain what is a rigid body? It is nothing but a body which will transmit force. Okay, with little deformation. That type of body is known as rigid body. Okay, a link is defined as a rigid body having two or more pairing elements which connects in other bodies for the purpose of transmitting force or motion. Okay, so each part of a machine which move relative to another part is known as kinematic link or element. So here frame and crank, they are links. Crank connecting rod as a link. So different links are, it's a four link mechanism. So what are the links over here? I will be writing here. First one is frame. Second one is what? Crank. Okay. Third one, what is the third link? Connecting rod. And fourth one is piston. Is it clear for you? So these are what we called as link. So when you define a link, each part of a machine which move relative to some other part is known as kinematic link or element. Okay, now is it clear? So here frame is a link, crank is a link, connecting rod is a link, piston is a link. So I think the concept is clear. Shall I move further?
Yeah.
Next is types of link or element. So we have told about what I mean by binary link. When a link is connected with two other links, it is known as binary link. Here you can see two links are there. Okay. Here this link is two links are there. Similarly, two links are there. So this type of links are known as binary link. When a link is connected to other two links, it is known as binary link. If you are connecting another link to this is a binary link. This is a binary link. Okay. Then ternary link means if three links are connected to a point. Three links are connected. Here, two links. Here, when three links are connected to a point, this is known as ternary link. Okay. If we are connecting four links to a point, it forms quaternary link. Okay, concept is clear now. So there are binary links are there. Then ternary link is the quaternary links. If two links are connected to a point, it forms a binary link. If three links are connected to a point, it forms a ternary. When four links are connected to a link, it is known as quaternary link. Next is classification of link. Classification of link. That in that first one is rigid link. Okay, so rigid link is one which does not undergo any deformation while transmitting forces. That type of link is known as rigid link. Okay, so what is rigid link is that it will not undergo any deformation while transmitting forces. An example is piston cylinder mechanism. Piston cylinder mechanism is the example. But you have to understand one thing, that rigid link does not exist because while transmitting, undergoing some transmission, there will be some deformation. Okay, so the best example what we see is this piston. Okay, that is the example what we say over here for a rigid link. But basically, you have to understand one thing, that rigid link does not exist because while transmitting forces, there will be some deformation. Okay, it is sure. Then flexible link. Flexible link is one. That is what? One which is partly deformed in a manner not to affect the trans. Hello? Am I audible? Shall
Yes,
I-
yes, yes. Audible.
Okay. So next is
Continue,
flexible.
continue.
Okay. Flexible link means a link which is partly deformed in a manner not affecting the transmission of the motion. So this is a belt. Belt drive is an example. Okay. You may say belt will transmit motion from one part to another with little deformation. Okay. That type of link is known as flexible link. Next is fluid link. Fluid link means the link, the transmission of forces will be with the help of a fluid. That type of link is known as fluid link. A fluid link is one which is formed by having a fluid container. The motion is transmitted through the fluid by pressure and compression only. So through pressure and compression, when the forces are transmitted, that type of link is known as fluid link. Okay, so there will be always a fluid over here. So next is kinematic pairs. Kinematic pairs means the link of a mechanism must be connected together in some manner in order to transmit motion from the input link to output link. These connections or join between the links are known as kinematic pairs. So you can see there is one link over here, there is another link over there. This link is revolving. Okay, you can revolve this link. Okay, this forms a kinematic pair. So that, as the definition suggests, the link of the mechanism must be connected together in some manner in order to transmit motion from input link to output link. These connection joints between the links are known as kinematic pair, or two link or element of a machine when contact with each other are said to form a pair if the relative motion between them is completely or successfully constrained. The pair is known as kinematic pair. Okay, what do you mean by successfully constrained motion? That I will say. So when two link or elements of a machine, when in contact with each other, is said to form pair if the relative motion between them is completely or successfully constrained. The pair is known as kinematic pair. Okay. So I have told you constrained motion. What do you mean by constrained motion? Okay. So I have starting from the first definition itself, I have been saying about what I mean by constrained motion, successfully constrained motion, etc. So we will explain what is this, what is mean by completely constrained motion or successfully constrained motion, that we will explain. So next is types of constrained motion. In that first one is completely constrained motion. So completely constrained motion means in any way, if you apply the force, okay, the force direction can be in any way, but the direction of motion of the pair is limited to one direction or limited to a definite direction. That type of motion is known as completely constrained motion. So what I mean by completely constrained motion? When the motion between a pair is limited to a definite direction, irrespective of the direction of force applied, then the motion is said to be completely constrained motion. So you may see the specialty over here. Here, they have fixed the motion in reciprocating direction only. Okay, whatever be the force applied, it will not rotate. Okay, the rotation is locked by some mechanism, and the only specialty is they will move, they will reciprocate. So this is an example of completely constrained motion. In whatever way the force we apply, the only effect of this is, or this mechanism is, it will be reciprocating inside the bar. Okay, it will not rotate. So we have stopped the rotation of the motion. So this is known as completely constrained motion. Okay, I think the concept is clear what I mean by completely constrained motion. Next is incompletely constrained motion. So example, you may see, this is an element over here. We have applied a shaft inside this one. Okay. This shaft can reciprocate as well as rotate. Okay, this shaft can reciprocate as well as rotate. This type of motion is known as incompletely constrained motion. Okay, when the motion between a pair can take place, when the motion between the pair can take place in more than one direction, then the motion is said to be incomplete constrained motion. Okay, when the motion between the pair can take place in more than one direction, then the motion is called incompletely constrained motion. A circular bar or shaft in a cylinder hole. You can see circular bar or shaft in a cylinder hole is an example of incompletely constrained motion. Okay, what is the specialty? You can see this can slide, also this can rotate. Okay, so two motions are possible. Okay, these two motions have no relationship with each other. So you may see, so incompletely constrained motion means when the motion between the pair can take place in more than one direction, then the motion is called incompletely constrained motion. A circular bar or shaft in a circular hole is an example of incompletely constrained motion. Okay, so this is the example of incompletely constrained motion. Then the next thing is successfully constrained motion. So successfully constrained motion means when the motion between the elements forming a pair is such that the constrained motion is not completed by itself, but by some other means, the motion is said to be constrained motion. Okay, you may see this shaft in the footstep bearing, it is load is applied, so it will not, so the rotation. So that is the specialty. It will not rotate. It will move up and down. Okay, this is due to the load application from the upper side. So this type of motion is known as successfully constrained motion. Okay. So these are the basic things about motions. So in the last class, I have told you about what I mean by successfully constrained motion, etc. So this class, I have explained what you mean by these type of motion. Okay. So next thing what you are going to study is kinematic chain. This is there in the note in the last class, but I was not able to explain due to time limit. So what I mean by kinematic chain. Okay. So example is that kinematic chain. What I mean by kinematic chain? When you define a kinematic chain, so we have got different kinematic pairs. So it is a combination of kinematic pairs joined in such a way that each link forms a part of two pairs and the motion them is relative to other is definite. So that means kinematic chain means if you are having a 4-bar mechanism, you may see this forms a kinematic chain. This becomes fixed. This is 1, 2, 3, 4. Okay. When they are connected corresponding to fixed link, the crank will rotate. Okay. This motion will be transmitted by connecting rod. Okay. To the follower. This is known as follower. Okay. So this is a kinematic chain. Okay. So when we are connecting the last link to the first link, there will be a definite motion that forms a kinematic chain. So if this is a 4-bar mechanism, so you may see when this 4-bar mechanism rotates, okay, this connecting rod will move this follower also in the direction, okay, to the left as well as right. So due to this motion, there is a motion for this, there is a reciprocating motion for this follower also. Okay, so this forms a kinematic chain. I think the concept is clear what I mean by kinematic chain. Okay, so then in the last class we have discussed about locked chain, etc. So, but we have not derived or we have not studied how to explain these chains, how you will be explaining these chains or how you will be finding out these locked chains, etc. So this class we will discuss that also. So the relationship between, so there is an equation. So L is equal to 2P minus 4. Okay, everything is there in the PPT, don't worry. Okay, just I am just doing this numerical so that you can understand this one. Okay, that's one. L is equal to 2P minus P. So L is the number of links and P is the number of pairs. Okay, okay. So then there is another equation. J is equal to 3 by 2 L minus 2. Okay, in that J is the number of joints. Okay, so L is equal to 2P minus 4. In that L is the number of links, P is the number of pairs. Similarly, J is equal to 3 by 2 L minus 2, where J is the number of joints. So first is the relation between number of links and pairs. Second is the relation between number of joints and links. Okay, so you have to understand the concept. If LHS is greater than RHS, okay, if LHS is greater than RHS, this forms what? Locked chain. Okay, when LHS is greater than RHS, it forms locked chain. Okay, when LHS equal to RHS, okay, this is the chain is constrained. Constrained. Okay, if LHS less than RHS, chain is unconstrained. These are the concepts. Okay, these are the concepts. So the chain to be constrained, what is the specialty? LHS should be equal to RHS, and we can say the chain is constrained. Okay, so we will solve a simple example so that you will be understanding the concept properly. Okay, so you have to understand that L is the number of links, P is the number of pairs, and J are the number of joints. Similarly, I will be explaining what are joints, pairs, etc. Last class also we have discussed this, but we have not done the numericals. So we will do numericals here. Simple concept to understand how this link is formed. So these points, if 1, 2, 3, this is A, B, C. So this point A, B, and C are known as joints. What are joints? A, comma, B, and C are known as joints. Similarly, 1, 2, and 3 are known as links. Okay, then this 1 and 2 will become pair. Okay, this 2 and 3 is another pair, and 3 and 1 is the another pair. So I think how to find out these pairs, links, and joints. I think the concept is clear now. What is joints, what is links, and what is pairs? How to calculate this one? Shall I proceed further? There is no doubt with links, joints, and pairs. No, when you do the numericals, or when I saw
joint is I can understand and link is okay. Pair one more time, tell me.
Okay, pair I will explain. pair means you have to consider it as a couple. Okay, so here you see 1 and 2 are coupled, no, with this joint. Okay, so this forms one pair. Okay, no.
Okay.
Then 2 and 3 is connected, no, through this joint. So this forms another pair. And
Okay,
3 and
okay.
1 is also connected this with, no. This forms another pair. Okay, no.
Okay.
So here,
Okay.
here there are 3 pairs, 3 joints, 3 links. Okay.
Okay.
Okay. So we will
Thank
solve one simple numerical, so you will understand this thing. So here, can you see there is a 3-bar mechanism over here. So this is 1, 2, 3. For our convenience, we are naming it as A, B, C. Okay, so write the number of joints over here. Number of joints is equal to 3. Okay, number of links is equal to 3. Number of pairs is equal to 3. Once again, I will explain. A, comma, B and C are the joints. 3 joints are. Similarly, 1, first link, second link, third link. So 3 links are. Similarly, 1 and 2, pair 1, 2 and 3, pair 2, 3 and 1, pair 3. So how many pairs are there? 3 pairs are. So what is our equation? L is equal to 2p minus 4. How many pairs are there? 2 into 3 minus 4. So what is 6 minus 4? The value is 2. Okay, the concept is clear for you. Any doubt? So next is joints. Joints is 3 by 2, L minus 2. Okay, so here you may see links. How many links are there? 3. So LHS greater than R. Okay. Okay.
How you come to get this one?
Any doubt?
You said L equals to 2p minus 4.
2p minus 4.
You said L equals to 2p minus 4. Where do 4 came from?
So this is the equation for this is the relation between number of links and the pairs. That is L is equal to 2p minus 4. From here, you know that 1 and 2 are the pairs. Similar first pair. This is one pair. 2 and 3 is the another pair. 3 and 1 is the another pair. So how many pairs are there? 3 pairs are there. So when you calculate 2 into pair value 3 minus 4. 6 minus 4, the value is 2. Similarly, number of links. How many links are here? 1, 2 and 3 links are there. So we know 3. So LHS value, number of links value is greater than RHS. Okay.
Okay.
Okay. Concept is clear, no? Now, when it comes to join 3 by 2, how many joints are there? 3. 3 by 2, how many links are there? 3 minus 2. So it is 9 by 2, that is 4.5. Minus 2 will come. So the value is 2.5. So here also LHS greater than RHS. So both cases LHS greater than RHS. So what was your concept? If LHS is greater than RHS, it forms what kind of chain? Locked chain. This concept what we have already studied. I think the concept is clear now. So what is the example of locked chain? Locked chain means it is a structure. What are structures? Structures. Bridge is a structure. Then our house is a structure. Okay. Similarly, all the bridges are structures. All the constructions are structures over there. Okay. So when LHS is greater than RHS, it forms a locked chain and it forms a structure. Okay, all the locked chains are structure. It will not be having any motion. I think the concept is clear for you. Any doubt?
This concept is okay. Can I give you one example for LHS less than RHS?
Equal to LHS equal to RHS. I am going to explain next one.
Okay.
Okay. Let me rub this and I will explain that. So we will move to a 4-bar chain. Okay, so this is link 1, this is link 2, this is link 3, and link 4. Okay, now. So link 4. So this is A, this is B, this is C, and this is D. Okay, so these A, B, C, D are what? Joins. 1, 2, 3, 4 are links. Similarly, 1 and 2 because so I will write number of joins. Number of joins is 4. So J is number of joins. We have already discussed A, B, C, and D. In that, A is one joint, B is another joint, C is another joint, and D is another. So number of joins is 4. Okay, number of links L 1, 2, 3, 4. 4 links are there. Okay, now. Okay, now pairs. 1 and 2 will become first pair, 2 and 3 will become second pair, 3 and 4 will become third pair, 4 and 1 will become fourth pair. So number of pairs is 4. Okay, so number of joins is 4, number of pairs is 4, number of links is 4. Okay, so our equation is what? L is equal to 2p minus 4. Okay, number of links is 4. 2 into number of pairs is 4 minus 4. So 2 into 4, what is 8 minus 4? This value is 4. So RHS is 4, LHS is also 4. So what is that? LHS equal to RH. Okay, now concept is clear now. Any doubt? Now similarly, J is equal to 3 by 2 L minus 2. Okay, so what is the number of joins over here? 3 by 2 L minus 2. What is the joins is 4. 3 by 2 into links is 4 minus 2. Okay, so 2 and 2 will get cancelled. 3 into 2, 6 minus 2. The value is 4. So here also 4, LHS also 4. So LHS is equal to RHS. Okay, so when this LHS equal to RHS, what for it forms what? Chain is constrained. Constrained means it is having some motion. Okay, it's a constrained motion in one direction or etc. Okay, so when LHS equal to RHS, the chain is constrained. So from this both the concept, you may understand that link 3, if you are having 3-link mechanism, it forms what? Structure. Always structure. Okay, if 3 links are there, you have to understand that it is a structure. Okay, so the basic thing for being a mechanism is what? It should be a 4-link. Okay, then only there will be a mechanism. If it is a 3-link, the mechanism is what? If it is a 3-link mechanism, it is known as a structure. And the basic thing for a mechanism to happen, it should be a 4-bar mechanism. I think everything is clear for you. Okay. Example is clear, no?
Yeah, okay.
Next is degree of freedom. So I have been saying in the class itself what I mean by degree of freedom. Okay, so actually anyone can reply how many degree of freedom are there for a body, actual body. Can anybody have a concept regarding degree of freedom? If you have, you can interact with me. Okay, if you have any idea about degree of freedom. For example, degree of freedom. What do you mean by degree of freedom? The name itself suggests what do you mean by degree of freedom. For example, this is X. Okay, this is Y, and this is Z. Okay, the 3D mechanics, 3-dimensional. And you're taking 3-dimensional. Okay, so if you consider a body, if you are placing a body over here, okay, it's a simple concept. If you are placing a body over there, what is specialty of this body? It can move in X direction. Okay, no? It can move in Z direction. Similarly, it can move in Y direction. So 3 already, 3 degree of freedom. Okay. Already we have found out 3 degree of freedom. Now, this body can rotate about X-axis. Okay, no? This body can rotate about Z-axis. Similarly, this body can rotate about Y-axis. So how many are there? Plus 3 more are there. So total, how many degree of freedom is there? 6 degree of freedom. Okay, now concept is clear now. So it will be having translatory motion in all the directions. Similarly, it will be having rotation motion in all the directions. So the total degree of freedom is how much? 6. Okay. Concept is clear now.
Okay.
But that motion will be constrained to a definite thing. Okay. That is the thing. Now, we have last class, so we will be discussing now. Last class we have discussed about some of the mechanisms and inversions of mechanism. So I think you are clear with this degree of freedom. We will be moving to another slide. Okay. So this was the slide what we are discussing about kinematics, kinetics, etc. in the last class. Mechanism, machine, then degree of freedom. We have given a simple example of mechanism, etc. Then we have told what we mean by inversion of mechanism. I think if you have any doubt regarding those things, I will give you a definite idea what is meant by inversion of mechanism. So, for example, if you are using a one, two, three, 4. Okay, this is a 4-bar mechanism. So this link 1 is fixed. Then you may see 2 will be rotating, 3 will be connecting the mechanism from 2 to 4, and 4 will be having a definite motion with respect to 2. So this forms a mechanism. So what is the basic criteria? In the last class itself, I have told you, for a mechanism to happen, one link should be fixed. Okay, to mechanism to happen, one link should be fixed. Okay, then only mechanism will be there. So what I mean by inversion of mechanism is that we will be changing this fixed link. Now, if 1 is the fixed link, if you fix 2, we will get 1 inversion. When you are changing it to 3, you will get another inversion. And when you are changing it to 4, you will get another inversion. So these are known as inversions. Okay. When we are changing the fixed link of a mechanism, you will be getting inversions of mechanism. Okay, that is what mechanism and inversion of mechanism. When we have discussed about mechanism and inversion of mechanism, this was the concept. So mechanism is when one link gets fixed, it forms a mechanism. And when we are changing that fixed link of that mechanism, will form inversions of mechanism. Okay, this is what we have studied in the last class. Now we have gone with 4-bar mechanism and basic idea of 4-bar mechanism, and then we have studied inversions of 4-bar mechanism. Basically, for inversions we have studied beam engine, coupling rod of locomotive, and Watt's indicator mechanism. This thing we have already discussed in the last class with these figures, and I have already shared a YouTube link also with this. I will share you with this one. You can see this YouTube link, and you will get a definite idea of this mechanism what we discussed in the last class. Then beam engine, coupling rod of locomotive. This you might have seen in films also. When you see steam engine, this type of mechanism you can really see. Or here, one wheel is coupled to another wheel. So when there is a motion to one wheel, it will be taking the other wheel also together with them. Okay. Then Watt's indicator mechanism. So these are the mechanisms. Then what is coming is slider crank mechanism. This also we have studied in the last class what will be single slider crank mechanism. So basic concept is what there will be a slider in the first. When we start this session, we have explained this single slider crank mechanism. So we will be knowing the concept of single slider crank mechanism. Then we have studied this inversions of single slider crank mechanism in the last class, that is pendulum pump or bull engine. Okay, so this is the first inversion. Then it was oscillating cylinder engine. Then third was rotary internal combustion engine. Okay, then this was crank and slotted lever mechanism. So last class I explained you. This is slotted lever quick return mechanism. Here the cutting time will be more as compared to the return time. Also the cut will be happening only in the forward motion. So that type of mechanism is known as crank and slotted lever quick return mechanism. You have to understand that when there is a forward motion, the time taken for forward motion will be more, and also cutting will be happening only in the forward motion. There will not be any cutting in the return motion. Okay, so the return motion will be slow. Next, what we are going is with quick return mechanism. It is same as that of crank and slotted lever mechanism. The only difference is return. This is another type of mechanism as compared to when we compare with this crank and slotted lever mechanism. It is with quick return mechanism. Similarly, here also the forward stroke, the time taken for forward stroke will be more, and the time taken for return will be all less. Okay, that is why these mechanisms are known as quick return mechanism. And also the specialty is that during forward stroke only the metal or whatever part is there, it will be cut. There will not be any cutting in the return motion. Okay, so this was the concept up to which we have discussed in the last class. Now there is one more inversion you have to study. This is double slider crank mechanism. So double slider crank mechanism, when you say about double slider crank mechanism, okay, so it is what you see means there will be two turning and two sliding phase. That type of mechanism is known as double slider crank mechanism. There will be two turning phase and two sliding phase. That type of mechanism is known as double slider crank mechanism. Okay, so for example, if I draw a figure of double slider crank mechanism over here, you may see there will be one slider over here, and there will be another slider over here. Okay, so when this is sliding, this also will slide. So two sliders are there. This link will also turn corresponding to this one. Okay, so there will be turning pair over here. There will be another turning pair over here. Okay, this type of mechanism is known as double slider crank mechanism. You have to understand that there will be two sliding as well as two turning pairs for this mechanism. That is known as double slider crank mechanism. Next is inversions of double slider crank mechanism. In that, the first inversion what you are going to study is elliptical trammels. It is nothing but this is an instrument for drawing an ellipse. The electrical trammel is an instrument used for drawing ellipse. Okay, so here there is a slotted bar over here. Okay, we will be fixing this slotted plate. Okay. The fixed plate or link 4 has two straight grooves cut in its right angles to each. The link 1 and link 3 are known as sliders, which will form the sliding pair. Okay, just leave it like this. You have to, I will explain what is the concept over there. You may see there is link 1, which is a slider, which is fixed. Okay, okay, that means that here this link is fixed. The slider will move inside this one. Similarly, there is a slider link 3. This will also move downwards and upward according to motion of this bar. So what we do is when we place a point pencil over here, and when this mechanism start running, what happens? This will move downwards inside the group. Similarly, this will move right direction. So this pen, sorry, it will move toward left direction. So this pencil connected to it will move in the direction as it will trace a ellipse. Okay, that is the specialty of this mechanism. So it will be moving inside this like this. This A and B will be moving inside the bar like this. Okay, so the pencil attached to it will trace the path of an ellipse. That is known as elliptical trammer. So this is basically an instrument used for drawing ellipse. Okay, you can see if you are not having that concept clearly, just see a video, YouTube video. When you see this YouTube link or a video, you will understand this concept. So basically, when you place a pencil over there, this pencil will tracing the path of ellipse at the motion between this slider. So this slider will be moving up and down inside the groove according to, there is a groove inside that. So one link will be moving down, it will be moving left side. When it is going back, it will be moving towards right side. So whatever pencil attached to it, it will be having the path of an ellipse. Okay, that is known as elliptical trammer. So this is the first inversion of a double slider crank mechanism. Next is Scotch-Yoke mechanism. So this mechanism is used for converting rotary motion into reciprocating motion. So here in Scotch-Yoke mechanism, you have to understand that whatever is there, it will be whatever rotary motion is there, it will be converted to reciprocating motion. You may see. So this is frame will be fixed, link 4 will be fixed. There will be link 1, there will be crank connected to a slider. And so you may see one slider here and another piston cylinder mechanism is the another slider. Those two sliders are there. Okay. Okay. So when this BA starts rotating, crank starts rotating, this slider inside the sliding bar will slide, reciprocate, which will take this piston cylinder mechanism in reciprocating direction. So whatever rotary motion is applied over here, whatever rotary motion is applied, it will be converted into what? Sliding or reciprocating motion. Okay. Concept is clear, no? When this crank rotates like this slider will also move together with the crank, and the slider inside, a slider inside the slider bar will move up and down, which will take this piston cylinder mechanism also to the left and right direction. So what is this direction known as? Reciprocating direction, reciprocating motion. Okay. So whatever rotary motion you are applying over here, whatever rotary motion is applied over here, it is converted into reciprocating motion. So this is another inversion of double slider crank mechanism. So what is that? Explained in the first slide. This mechanism is used for converting rotary motion into reciprocating motion. The inversion is obtained by fixing either link 1 or link 3. Okay, the concept is clear. Clear, no?
Yeah.
Next is Oldham's coupling. Okay, so this Oldham's coupling you might have seen. It is nothing but if there are two shafts, this is one shaft over here, and another shaft is there. Okay, so when there is a distance between the centers of these two shafts. Okay, when there is a distance between centers, okay, two parallel shafts are there, and if they are having a distance between the centers, when these types of shafts are used when this type of shaft have to be connected, we will be using Oldham's coupling. Okay, Oldham's coupling. Okay, so Oldham's coupling is used for connecting two parallel shafts whose axes are at a small distance apart. The shafts are coupled in such a way that one shaft rotates and another shaft also rotates at the same speed. Okay, so Oldham's coupling, you have to understand this. The Oldham's coupling is used for connecting two parallel shafts whose axes are at a small distance apart. The axes are at a small distance apart. The shafts are coupled in such a way that one shaft rotates, the other shaft also rotates at the same speed. Okay, so if you see the figure over here, you may say this is the driving shaft A. So this frame is fixed. This is this link, first link is fixed. The frame is fixed to this surface. This is driving shaft A. A is rotating. This A is the rotating shaft. Okay, this is known as A is known as a rotating shaft. Rotating shaft. Okay, so this A will be rotating. So we are placing another Oldham's coupling here in between. This is known as Oldham's coupling. Oldham's coupling. Okay, is placed in between these two. There is another shaft B. So this center distance of B and this center distance of A, there is a slight difference between these two centers. These shafts are parallel, but there is a distance between these two centers. So in order to connect this one, we are using an Oldham's coupling in between. Okay, so shaft A is connected to this Oldham's coupling. Similarly, shaft B is also connected to this Oldham's coupling. So what happens when this shaft A rotates, it will be shared to this Oldham's coupling. So the shaft B connected to this Oldham's coupling will also rotate at the same speed at which the A is rotating. So this is used for connecting the two shafts which are at a parallel shaft whose center are at a slight distance, or they have centers are not parallel shaft whose centers are acting at a slight difference or a slight eccentricity is there. In that case, we will be using this Oldham's coupling. Okay. So if the two centers of a shaft are at a distance, at a small distance apart, at that case, we will use this Oldham's coupling. So this is another inversion of a double slider crank mechanism. So when you are seeing about these concepts, you may understand over here. So this is when you study about double slider crank mechanism, there are three inversions. One is electrical trammel. What is electrical trammel? It is a device used for. Next is what? Kochok mechanism, which is used for converting rotary motion to. Similarly, the last is Oldham's coupling. This is used when two parallel shafts whose axes are at a small distance apart. We will use Oldham's coupling. So whatever motion is given to this driven shaft will be transported to driving shaft will be transported to driven shaft with the help of Oldham's coupling. So these are the inversions of double slider crank mechanism. So these are the basic things about theory of machine and what you mean by mechanism, what you mean by inversion of mechanism, and what you mean by kinematic link pair, etc. So these are the basic things what you study about theory of machines. So I think whatever I have taken is clear for you. Okay, I will share this PPT with you. Okay, I think the concepts are clear. So if you have any questions regarding this subject, you can ask me. Okay. So if it is okay, we can wind up the class for today. So I think concept what I have taught is clear for you. Okay. If it's okay, thank you.
Thank you.
Okay, thank you.
Thank you.
For the link, how to get link? Hello.
YouTube link. YouTube link.
Yeah. Yes. Yes.
That is there in the PPT itself. You can just click that.
Okay. Thank you.
When I share the PPT, There is a link over there. You just click that. You will get that. You will
Okay,
be
thank you,
getting YouTube link over
This
there.
is our
Okay.
chat box.
Hello.
Hello. It is our chat box or where?
No chat box. When I share this PPT with you, no, in that PPT, in that where the note I have written, no, in the inversion note itself, in specific heading itself, the link is also given. When you click that link, you will directly go to YouTube and you can see the video.
Okay, okay.
Okay. So when you are shared with this PPT, you can see that. Okay. Okay. So,
Okay, thank you.
okay. Thank you.